What's up guys, it's Iman Fiaz and today's video is on AQA Level Chemistry Group 2 Metals question paper. Uh, I was on my YouTube channel, I was seeing how many question papers I've actually done, and I've only done 10. This will be the 11th one. So, and I'm pretty sure there's around about 27 topics in all of A Level Chemistry. I'm pretty sure there's that much, so still got a long way to go, but it's fine because yep, it's absolutely fine because going through these questions help me and hopefully they help you as well. Tap these kind of questions. So, question one, this question about magnesium is compound. Say one observation for magnesium reacts with steam. The observation, you just need to know these off by heart. White light, bright light, whatever. White light. These kind of questions, don't stress about them too much. If you see them in exam, you're like, I don't know. No, if you see them in past paper and you're like, I don't know, you just haven't reviewed the content enough. You just haven't learned, sorry, all the equations. So this equation again, steam, that's really important. It's not going to be H2O liquid. It's going to be H2O gaseous, and that's going to affect what my product is. So plus H2O gaseous, arrow, MgO solid. In this case, I have one magnesium oxide plus hydrogen. Oh, the equation should go there, but you get the point. Nice, 2 marks. Describe the bonding in magnesium. Um, can you guys see my screen? Yes, you can. So attraction between lattice of Mg2 plus ions and delocalized electrons. Would this come up in a real A-level exam? As a question, no, I don't think so. It's just too it's just not going to come up, I don't think. This could possibly come up. Explain in terms of structure and bonding while magnesium chloride has a high melting point. But again, this is still pretty simple. Giant ionic lattice, strong electrostatic forces of attraction. You can say between Mg2 plus ions and Cl minus ions, or you could just say between oppositely charged ions, which obviously require a lot of energy to overcome, and therefore it's got a high melting point. But you can put that bit in. This is like the 3 key details you definitely want to include. The giant ionic lattice, strong electrostatic force of attraction between oppositely charged ions. 2 key things. Give 1 medical use for magnesium hydroxide. Magnesium hydroxide is indigestion relief. It's something about your stomach. Indigestion. It is a laxative, yeah. Indigestion relief, or you could say neutralize excess stomach acid, or you could say laxative. Indigestion relief is fine. This definitely probably would come up because it's a 1 marker, just testing how well you know your content. And if you don't know it, you don't know it. What is it used for? Barium sulfate. What is barium sulfate? BaSO4. Now, this is a multiple choice question, so good thing about A-level chemistry is the multiple choice questions, you don't have to worry about them until paper 3, right? But in this case, so focus on paper 1, then paper 2, then paper 3. What is it used for? Barium sulfate. In agriculture to act as fertilizer to, well, I know that's magnesium hydroxide just from, obviously these questions aren't related to each other, but just from this part 1D. In medicine to produce an X-ray image, barium meals. Yes, it is. It is. I remember barium meals. Patient swallows barium meal, which is a suspension of barium sulfate. And yeah, it is a suspension of barium sulfate, and then it helps because X-rays usually pass through soft tissues. Therefore, it helps it show up. The organs and the intestines show up on the X-ray. Explained why the melting point of magnesium is higher than the melting point of sodium. Um, Mg2 plus has a higher charge density, so stronger attraction to delocalize C of electrons. But what is that? What is the attraction between a metal and delocalized C electrons? It's metallic bonding. So you could just say stronger metallic bonding. And in the exam, that's what I would do. You don't want to waste any time. Yes, it's only a couple of extra 3 more words, but every minute you can save in the exam, every second, so just say stronger metallic bonding instead. Forget that part. Mg2 plus a high charge density, stronger metallic bonding. Given the equation, how magnesium is used as a reducing agent in the extraction of titanium. Again, this is the equation you have to memorize. It doesn't say include state symbols, so I don't need to. There you go. 2Mg plus TiCl4 2MgCl2 plus Ti. And explain in terms of oxidation state while magnesium is a reducing agent. Well, I wouldn't recommend to memorize the oxidation states beforehand. That's just too much. Like already there's a bunch of equations in the whole available chemistry to memorize. Memorizing the oxidation states is just not relevant. It's just not worth it. Instead, master the skill of oxidation states. Well, obviously not master it, but you know what I'm saying. Try your best, and then you can see, well, that's 0. That when you include oxidation states, I don't really care about the number of moles, so I'm crossing them out. But obviously in the equation, don't cross 2 out. Cl minus 1, so that's going to be plus 2, and Ti, well, that's 0, and that's plus 4. So now I can talk about oxidation states. Well, I can clearly see magnesium changes from oxidation state 0 to plus 2. Titanium changes from oxidation state plus 4 to 0. So that's the first thing I'm going to do, is I'm just going to copy and paste that down. So magnesium has an oxidation, no, sorry, magnesium changes oxidation state, because that's what it does, from 0 to plus 2. And what does that mean? Well, if it changes oxidation state from 0 to plus 2, so electrons are lost. Everything's opposite. They gain in charge, electrons are lost. And you can say then titanium changes oxidation state from plus 4 to 0, so electrons are gained. This is a question I would really put on a flashcard. Not this equation, because you already need to know this equation up by heart, but in this one, because it is very specific. You need to say magnesium changes oxidation from 0 to plus 2. And not only that, then you need to say so electrons are lost. And you also need to say titanium changes oxidation state from plus 4 to 0. Not only that, so electrons are gained. Definitely could come up on the paper. State what is observed when dilute aqueous sodium hydroxide is added to a separate solution of magnesium chloride and barium chloride. Magnesium chloride, slight white precipitate, slight, because of the magnesium, remember, slight white precipitate. Barium chloride, the barium, no visible change. Because remember, barium is the only metal that has no visible change when dilute aqueous sodium hydroxide added to it. So you need to know your test very well so you can apply it to this kind of question. So slight white precipitate, no visible change. Given the equation reaction between titanium 4 chloride and magnesium, again, a repeat of a question. So I'm not even going to have to, I'm just going to copy and paste from here. So 2Mg plus TiCl4 arrow 2MgCl2 plus Ti. Perfect. So you can hopefully see how they like to reuse questions. Is it exact? Is it exact wording? No, this is slightly questioned because this one's also asking why is a reducing agent. And role of magnesium, therefore, is a reducing agent. Reducing agent. So 2 mg plus TiCl4 are 2 mg Cl2 plus Ti, reducing agent. That's the role of magnesium in this reaction. A mixture of magnesium oxide and magnesium hydroxide has a mass of 3,200 milligrams. The mixture is reacted with carbon dioxide to form magnesium carbonate water. Mass of what produces 210 milligrams. Calculate percentage by mass of magnesium oxide. It's a mixture, 4 marks. So it's not going to be like a walk in the park. It's 4 marks. It's definitely going to be some traps with this question, especially with these math questions. So a mixture of magnesium oxide and magnesium hydroxide. So let me just, I like to write it down in terms of equation. So plus this has a total mass of 3,200 milligrams. And I know the mass of water produced is this, water, or mortars here. So already now I can figure out what's going on. So I'm going to have to find out the moles of water, a 1-to-1 molar ratio. I work out the moles, I've got the mass, I've got the moles of this, I can work out the mass of this. Then I can then calculate the mass of magnesium oxide, because magnesium oxide mass equals 3,200 minus the mass of whatever magnesium hydroxide is. So I'm just going to label it M. The only trick then is milligrams. Milligrams to grams. Milligrams to grams divided by 1,000. So 3.2 grams. Should I leave it milligrams? Yeah, let's leave it milligrams for now. Let's leave it milligrams for now. No, I can't, because moles mass over mR, I need mass to be in grams. So moles equals 3.2 over, no, sorry, 0.210 over mR of water. And then I know it's a 1-to-1 molar ratio. I get the moles of magnesium hydroxide. And then to find out the moles, I've got the moles of magnesium hydroxide. Therefore, I can work out the mass of magnesium hydroxide. Moles of mass of mR. Mass is moles times by mR. Then I can work out the mass of magnesium oxide, 3,200 minus my answer. And then put that out of the total mass, which is 3.2 grams. It's percentage by mass. So percentage by mass means the mass of magnesium oxide over this mass of magnesium oxide, magnesium hydroxide, times by 100 percentage, should get 78.7%. Not too difficult. You just need to be really confident converting between milligrams and grams, which you should be, and also just reading the question properly. And then, yeah, that's it. Which property would you expect the element radium Ra to possess? Radium, again, what is radium? Radium is a metal. So already off the bat, can I see something? Yes. It's a good conductor of electricity. Well, obviously, it's a metal. Question 6, which statement is not correct? So I don't like this. I like to say which statement is false. Don't know why there's so many multiple choice questions. Strontium has a low first ionization energy to calcium. Well, I do need to get my periodic table out. Put in the light. Periodic table. I need that periodic table. So strontium, calcium, no strontium. Where's calcium? Where's calcium? Where's calcium? Calcium. Okay, so strontium would actually have a lower first ionization to calcium because I'm basing it on the general trend first ionization to decrease cost period. So that's true. So that is not the statement I'm looking for. You see, you can see how it can be complexing. It's quite difficult because you're like, but that's true though. Yeah, but it's asking for the opposite, which one's false. Strontium has a larger ionic radius than a calcium, but if it's got a lower first ionization energy, then obviously it's going to have a larger ionic radius. Strontium reacts less vigorously with water than calcium. Yeah. Which number of the group 2, which property group 2 elements, Ca to Ba, increases or reduces atomic number, atomic radius, electronegativity, first ionization energy, melting point. First ionization energy decreases down the group, so that's not it. Electronegativity, that would also not increase because electronegativity is the ability of an atom to attract a pair of electrons in a covalent bond. But if you're increasing when you go down from Ca to Ba, more electron shells further away from the outer electron shell, further away from the nucleus, so it's not going to be able to attract those electrons as strongly. And that is definition of electronegativity, the ability of the atom to attract a pair of electrons in a bond. So I'm left with A and I'm left with D. Melting point. Well, no, because that's another trend you need to know. Therefore, the answer is A. The idea of melting point, well, the size of the ion doesn't change. Size of the ion doesn't change. The number of delocalized electrons per atom doesn't change. The charge in the ion doesn't change. Sorry. The only thing that you're adding is more electrons, so it's actually not going to increase. What is the correct observation when barium metal is added to an excess of water, forms a colorless solution, and effervesces? Aqueous solution of salt gives white precipitate mixed with aqueous silver nitrate, mixed with dilute sulfuric acid, which could be formed as salt, barium chloride. Which substance is used to reduce titanium 4 chloride in the extraction of titanium metal? Magnesium, again, so they can ask you actual questions on it, or they can ask you multiple choice questions on it. They can ask you anything in this, and they love to ask about titanium 4 chloride in the extraction of titanium metal. Which statement about barium sulfate is correct? It is soluble in water at a temperature of 100 degrees Celsius. It is used in medicine. That's it. Because I know that barium sulfate is used in medicine. So therefore it must be B. Because it does not dissolve in bodily fluids. I don't know. I don't know if that's true or not. But I don't care. Because think about the exam, right? These multiple choice questions are testing your knowledge, right? A lot of them. And on spec points. Is barium sulfate used in medicine? Yes. Have I ever seen being asked on this or this or this? No. And it does also not dissolve in bodily fluids. Because the patient swallows the barium meal, which is a suspension of barium sulfate. Which compound is used to treat the symptoms of indigestion? Well, calcium hydroxide is used as an antacid to neutralize acid soils. No. Yeah, it's magnesium hydroxide. You probably get confused between MgO. I think that's what most students would get confused between. But yeah, don't get confused between. That's magnesium oxide. Give the full electron configuration for the calcium ion Ca2+. Okay, now back to exam questions. So Ca2+, well, calcium has got 20 electrons. So anytime I've got a question like this, I just draw out the normal thing. So calcium equals 1s2, 2s2, 1s2, 2s2, 2p6, 3s2, 3p6. 1s2, 2s2, 3p6, 3s2, 3p6, 4s2. But it loses 2 electrons. 4, 10, 4, 10, 12, 18, 20. But it loses 2 electrons. So that's just going to disappear. So it's 1s2, 2s2, 2p6, 3s2, 3p6. Experiment with second ionization energy of calcium is lower than the second ionization energy of potassium. And if you look at the Mark scheme, and I'm on the Mark scheme right now, but with the Mark scheme, it's very general. It says in calcium, while it's lower than second, in calcium, the outer electron is further away from the nucleus, more shielding in calcium, or Ca+. That's what we're looking for. So I'm very surprised. I'm going to jot that down real quick. Being my second I dot E of Ca+ is lower than the second I dot E of K+. In Ca+, the outer electron is further away from the nucleus, more shielding. That's all it wants. Obviously in calcium, in Ca+. That's very unusual. Yeah, that's all it wants. In calcium, outer electron further away from nucleus, more shielding calcium. Identify the S block element that has the highest first ionization. I also hate these kind of questions as well. Don't know why. Well, S block. Well, if I look at lithium or beryllium, because I know first ionization energy decreases as you go down a group, increase across period. But I'm looking for the S block metal, and therefore I've only got lithium and beryllium. So I've got lithium 1s2, 2s, 1s2, 2s1, and I've got beryllium 1s2, 2s2. That's 4 electrons. So which one is going to have? You might think it's lithium, but it's actually not, because they're both in the same 2s orbital. But this one's just got 2 those electrons. So the highest first ionization energy is beryllium. Probably put this on a flashcard, to be honest. Definitely could reuse this one. Yeah. Give the formula of the hydroxide element group 2 from magnesium to barium that is least soluble in water. Magnesium hydroxide. Again, you could probably put that on a flashcard as well. Give an ionic equation for the formation of precipitate. Barium chloride, sodium sulfate. So you're going to form barium sulfate. So barium sulfate, Ba2 plus aqueous plus SO42 minus aqueous, and BaSO4 solid. Assume I did 6 centimeters cube of this much, of barium chloride solution to 8 centimeters cube of 0.15 mole per dm minus cube of sodium sulfate solution. Student filtered off the precipitate and collected the filtrate. Show by calculation which reagent is in excess. That's very easy. Just find out the moles. Moles of, I'm just going to label this. So that's barium chloride, concentration of volume, 6 divided by 1000 times by 0.25. And I've got the moles of sodium sulfate. I'm just going to label as Na as 8 divided by 1000 times by 0.15. So 6 divided by 1000 times by 0.25, 1.5 times by 10 to the power minus 3. 8 divided by 1000 times by 0.15, 1.2 times by 10 to the power minus 3. So which one is in excess? Well, it's obviously going to be the barium chloride then. Because obviously the barium chloride is in excess. But you might be wondering, Iman. But this is 10 to the power minus 3 and that's 10 to the power minus 3, so surely the bigger is more negative. So is that not in excess? Well, let's think about it. 0.0015 for barium chloride. I'm just going to label it. Let's just label it that. And then 0.0012 for sodium. 1, 2, 3, 1, 2, 3. Which one's bigger? Which one's bigger? Just tell me that. Well, let's cross off that. Cross off that. Cross off that. Cross off that. Well, 5 is bigger than 2. So therefore barium chloride is in solution. I probably could make a silly mistake there, but yeah, if you don't like the standard form, just write it out like in decimal place and then you can find out which one's in excess. So therefore you say barium chloride is in excess. And then the total volume of the other region. Well, I've got 6 centimeters cube of barium chloride and added to this much of 0.15 moles per dm minus cube of sodium sulfate solution. What is the total volume of other reagents which should be used to by students so the filtrate only contains one solute? Well, let's think about it. I've got 1.5 times by 10 to the power minus 3. I've got 1.5 times by 10 to the power minus 3 of barium chloride. I want the total volume of the other region, which should be used so the filtrate contains only one solute. Well, that's got 0.15 moles per dm cubed. So 10 centimeters cubed of 0.15 moles per dm minus cube sodium sulfate. There you go. Because if you get your calculator up and you put in 10 divided by 1000 times by 0.15, you get the same amount of moles, and therefore it only contains one solute because they both contain same number of moles, same n. So yeah, that's a bit of a weird one. But what you need to remember, because it says total volume of the other region, I've done barium chloride. What is the other region? Sodium sulfate. I can't change the concentration. It tells me the volume that should be used. Well, I need them to both have the same amount of moles, so I just need to manipulate the volume from 8 to 10. Bit of a weird one. I'm probably going to take a screenshot of this one. But once you get your head around it like that, it's very easy. State why the isotopes of strontium have identical chemical properties. And then calculate percentage abundance. So why they have identical chemical properties? Same electronic configuration. Same electronic what's the time? How long? 30 minutes, okay. Same electronic configuration. Calculate percentage abundance of the 88SR isotope in the sample. If you watch yesterday's video on atomic structure, there was a bunch of these questions and they were very challenging. But if you watched the whole of that video, thank you. And that means we should be able to do this pretty easily. 87.7 is relative atomic mass of that. 87.7 equals 86. Well, I'm gonna let something equal something. So I'm gonna let 86 SR equal Y. So equal 86 times by Y. Well, I could just say 86Y plus 87Y because they've got a 1-to-1 molar ratio. Plus 88. Okay, sorry. I'm going to put a plus here. 88 bracket what over is a percentage, so we divide it by 100. Well, I've got one Y here. I've got another Y here. So this part, the percentage of abundance, has got to be 100 minus the 2Y. That's what it has to be. Once you've got that, then it's easy from there. Move that to the right hand side, left hand side. Collect your like terms, collect the Y terms, and then you find out Y. But again, that's not your final answer, because once you find out Y, then you need to do so yeah. Let me see if that's right. So 87.7 equals 86. In the mark scheme it says X, Y is perfectly fine, plus 87Y plus 88 bracket 100 minus 2Y over 100. You get Y equals Y equals 10%. Then percentage of abundance of 88 isotope is 100 minus 2 bracket 10. 100 minus 20, 80%. Identify the ion with the longest time of flight. It's going to be this one because it's the heavy. It's got the highest MR. Very nice question. Very nice question. Oh no. Okay, I fell for it. I definitely did fall for it. It says the one that was ionized by electron impact. Electron impact sample is vaporized. Electron gun is used to fire high energy electrons at it, knocking one electron off each particle, becoming a positive ion. So therefore, it's 138 Ba plus, and you need that. I'm assuming you need that, otherwise you won't get any marks. Calculate length of the flight tube in meters. Okay, again, if you watch previous video, you see this question always. This came up a lot. This question. So what you need to do is take a deep breath, don't stress out, and just label everything you know. So Ke equals 3.65 times by 10 to the power minus 16. Obviously, if you're doing a past paper question, try to do it as fast as possible, I guess. But in a real exam, do not do that. Take your time. But Iman, what about, I've run out of time in the exam? Well, if you rush your time, you probably wouldn't get it right anyway. But as long as you took your time, and you guarantee yourself 5 marks, but just take your time, because you don't know what unfamiliar context they're going to give you in the exam. It doesn't necessarily have to be this format. It could be any kind of format. You need to have a plan, and the plan is label each thing out and then work from there. K equals that, time equals 2.71 times by 10 to the power minus 5 seconds. and I know I want to find the length of flight tube. Well, immediately velocity is distance over time. Length of the flight tube means the distance, so distance is velocity times by time. I have the time. I have the kinetic energy. This is the only thing I don't have. Well, how do I find out? Well, I've already memorized this beforehand, but you can rearrange it. Times by 2 divided by m, square root of it. But it's probably better to memorize it so you don't waste any time. So velocity is square root of 2ke over m. I've got kinetic energy, I need the mass. Well, because it's iron, I can work out the mass of the iron by doing m. Mass of the iron equals 0.137. So I need it in kilograms over Avogadro's constant. Again, if you watch yesterday's video, I say if Avogadro's constant comes up and they give it you 99% chance, you need to use it in your somewhere along the line. So divided by L, 6.022 times by 10 to the power 23. You get the mass, and then you can find out the velocity by substituting into there. And then once you got the velocity, you can find the distance by substituting into there. So then it's just a bunch of substitution. So yeah, find out the mass, find the velocity, substitute the mass into velocity, find the velocity, then substitute the velocity and distance as velocity time by time, get the distance as 1.54 meters. Which products are formed when magnesium reacts with steam? Now, this again was the previous question. If I scroll up a bit, but I don't really want to. Magnesium solid, steam, H2O gaseous. So it's a trick. If you put H2O liquid, you'll get a different product. You get different products. So in this case, you're going to get MgO solid plus hydrogen gaseous. So which products are formed? Well, magnesium oxide and hydrogen. So C. Question 15a. This question is about iron testing. Describe how a student could distinguish between aqueous solution potassium nitrate and potassium sulfate. Immediately, alarm bells go off. Sulfate ions, barium chloride. Well, the observation with potassium nitrate was going to be no visible change. No visible change. The observation with potassium sulfate is going to be a white precipitate. White precipitate because of the sulfate ions. Scalpel students could distinguish between aqueous solution magnesium chloride and aluminium chloride using a one simple test tube reaction. Magnesium chloride, aluminium chloride. Now, Iman, what would I do here? Well, look at the ions, magnesium, aluminium. So that's the only thing that changed. So again, it's how well you know your test tube reaction. Sodium hydroxide with magnesium chloride, it's a white precipitate. With aluminium chloride, it is also a white precipitate, but then how is that? How are we going to be distinguishing between them? But it's a white precipitate which dissolves in excess sodium hydroxide. Question 16a. Give a reason why the mass of the solid sample changed in the experiment. And it says strontium ore. Well, obviously because the carbon dioxide gas escapes slash is lost. Carbon dioxide gas escapes slash is lost. Use data in table to calculate mass of strontium, carbonate, and the original ore sample. Give your answer to appropriate precision. 5 marks. Boom. And you just give me a bunch of table of everything and like that. That's kind of scary for me. Not scary, but kind of intimidating. Like I don't know what formulas I'm using. I don't know any of that. I've got some sort of idea of ideal gas equation, but in reality, that's not anything I need to use anyway. So calculate the mass of strontium carbonate in the original ore sample. I've got the mass of the crucible ore sample, where the crucible, mass of the crucible and sample after first heating, mass of crucible and sample after second heating, mass of crucible and sample after third heating. So if I need to find out the mass of carbon dioxide, when strontium it decomposes to carbon dioxide, I sampled strontium oils that contain this, determine the mass, weighed the sample, heated it in a crucible, sample data to do that, carried out 3 times, the results set in the table. When it's heated, we'll just find out the mass of a sample of strontium ore contains strontium oxide, strontium carbonate, and some impurities. Determine the mass of strontium carbonate present. Weigh the sample of solid ore, weigh the sample of the ore, heated it. That's a heat. In a crucible for 5 minutes, so 300 seconds. Sample was then allowed to cool. It was cooled, so you've got ice. So I guess you can do like a snowman or whatever. And then it was reweighed, carried out 3 times, and here's the results. Okay. So it's done the first time. So that's the first time, right? Perfect. That was the first time. So after the first time, giving in this information, you've got your sample. Then it was done again the second time. But in this case, the sample, strontium carbonate is heated, decomposes to form a carbon dioxide. And that's the second, after the second heating. Because that's the first heating originally. So that is the mass of the... So in order to find out the mass of carbon dioxide, I'm going to do 16.11 minus 14.58. Mass of the crucible and the ore sample minus the mass of crucible and sample after second heating. So yeah, you need to get your head around that. 1.53 grams. And then you can work in the moles of carbon dioxide. Moles of 1.53 over mR. And then I can work out the moles of this, because 1-to-1 mole ratio, so it's the same. It's the exact same amount of moles. But then I can work out the mass of it, because I want to find the mass of strontium carbonate. Well, the mass is moles times by mR, so the moles times by the mR of strontium carbonate. And then, yeah, you get 5.13. I think this is an old spec question, because there's no way that is 5 marks for this. Like, obviously, it's still kind of tricky. You need to read the question a couple of times to identify what's going on, and then that's the second time, 16.11 minus 14.58 to get this. But then apart from that, then it's moles, mole ratio, mass. Nothing difficult. Calculate percentage error in initial mass or use. Each balance reading has an intensity of 5 milligrams. And I know how many questions are left. Oh, that's it. Very, very short. So, sorry. 5 milligrams, calculate percentage initial mass of ore used. Well, initial mass of ore used, well, I know I've got 5.13 in this strontium sample. So, well, the mass of the crucible is that, and I know I've got 5.13, but I know the mass of the crucible and the ore sample is that. So you can work out the mass by doing that. Subtract that, so it's going to be 0.01 over 6.26 times by 100, and you get 0.160%. Determine the mass of strontium oxide in the sample and justify any assumption made in calculating. Answer: the mass of net impurity is potential 47. The impurity is 2.47. We've got 6.26 is that, so it's just going to be 3.47. Oh, sorry, 6.26 minus 0.347 minus 5.13, and you get 0.783. And the assumption is that all strontium carbonate reacted as it was heated to constant mass. They love that word phrasing. Heated to constant mass. Write an equation for reaction and state the role of aluminium in this process. Strontium vapor and solid aluminium oxide are formed. So heating strontium oxide with aluminium metal. So I've got strontium. Okay, let's just forget all of that. This is not an equation on the specification as I'm aware. Strontium and aluminium, no. So strontium, but they can ask you equations just to construct one, right? Plus aluminium and forming strontium. That's that. Well, I know I'm going to have to form, well, it tells me aluminium oxide is formed. Alright, never mind, it's very easy then. It tells me aluminium oxide is formed, so then it's just just balancing it. So that's 2. I need I need 3 oxygen, so I've got a 3 here, I've got a 3 here. Yeah, perfect. It tells me the question. Just need to read it properly. And then it says state the role of aluminium in this process. This one's a bit more this one's slightly trickier because, well, let's have a look. Aluminium goes from oxidation state of 0 to, in this case, minus 2 times by 3 minus 6 to plus 3. And strontium, I don't care. With the oxidation state, I don't care about the moles. So I'm going to just put it in a box. Obviously, you do need to include the number of moles in the equation, balance equation. When in terms of oxidation state, I don't care about the number of moles. Just cross it out. So this oxidation state is 0. This oxidation state is plus 2. So it goes from plus 2 to 0, 0 to plus 3. So aluminium acts as a reducing agent. And 9 times out of 10, it's always a reducing agent. Remember with magnesium and titanium for oxide, that was also a reducing agent. I could have guessed the reducing agent, but I just wanted to show you guys the changing oxidation states. And obviously, you need to know the definition of reducing agent to understand what's going on, which I have forgot. Reducing agent definition. So now strontium forms vapor, but aluminium oxide forms solid. Well, strontium is collected as a vapor, as aluminium oxide is an ionic lattice, so has strong ionic attractions, whereas strontium is a metallic structure with metallic bonding. So it is formed as a solid. Oh, sorry, which is actually relatively weaker. And this comes with your understanding of metallic bonding versus ionic bonding. Ionic bonding is actually slightly stronger. Is ionic bonding stronger than metallic bonding? Yeah, in general, it is. Ionic bonding is actually ionic. It's actually stronger than metallic in general. It depends on the context, what element you're working with, etc., etc. There you go. Run equation reaction of calcium with water at 25 degrees C and predict the possible value for the pH of solution form. Now, this equation, you need to know it's like X solid plus 2H2O liquid to form X bracket OH squared plus H2 gases. So in this case, it's reaction of the group 2 metals with water, basically. So Ca solid. I don't even ask for. It doesn't even ask for oxidation for state symbols, so that's fine. Plus 2H12, calcium hydroxide plus H2. Possible pH. Well, calcium hydroxide 8 to 12, say 9. Stated trend solubility in water group 2 sulfates from magnesium to barium. Decreases in solubility from magnesium to barium sulfate. State region that can be used to test for the presence of sulfate ions. Barium chloride. Write a simple ionic equation for the reaction that occurs with the chosen reagent. So BaCl2 aqueous barium chloride ionic equation with the chosen reagent. So with this case, it's going to be Ba2 plus presence of sulfate ions SO4 2 minus aqueous to form BaSO4. Explain what multiple of calcium sulfate is high. Calcium sulfate Ca2 plus SO4 2 minus. So I'm like, okay, that's positive, that's negative ion. Calcium sulfate, well, it's got strong attraction between positively charged Ca2 plus ion and negatively charged SO4 2 minus ion. And that is it for the group 2 question paper.